a few moments. Okay, fantastic. The lecture is being recording. Good morning, everyone, again. I was just telling that the plan for the next 3 weeks, we are going to learn visualization in the lectures, and in the workshops there are like practices that we will do all together as a part of the workshop. I'll try to do the same system that Nushan had in the first 6 weeks, and then she'll come back in the last week to do a revision of the whole module. I have already posted an announcement like last week, I believe. The way that you have to install Tableau. I'll show you the name, etc. In this lecture as well. So it's a like 3 weeks lecture. This is the first one on visualization. We learn what is visualization, why it is important, and then we will see the software that we will use. So there are different ways of installing. It's not a free software. Indeed, it is expensive, and I will show you in the slides in a minute that you will see there are lots of companies and governments and people who pay a lot of money to use Tableau because this is an amazing software. So it's not free, but it is free for academic purposes. So you can either get a license to use, and if you got the license, you can go through the procedure that we have here in this slide, the steps to add the key to the software and use it. Alternatively, I guess if you sign in with your university email address, as I did, I registered myself years ago because I used to I'm teaching this module to UG level as well for the last few years. Because I'm registered as a lecturer. When I sign in and download the software in a new computer, they don't ask you to give any license, to provide any license or something. So that should be the same for you as a student. So please do this. In the workshops, in the next 3 weeks, we mainly focus on Tableau. So please bring your computer and make sure that Tableau is installed. Now, the learning objectives for today's lecture 1 of this series. What is data visualization? This is the first thing that we will focus on, and why we visualize data. And then we will cover what is Tableau, the software, how to load data in Tableau. I will show you as a part of the slides that we will practice and implement in the workshops next week. And we'll see some basic Tableau functionalities as a part of the lecture today. But first of all, what is data? This is a screenshot of, if you Google data, you will see this as the answer. Essentially, data is facts and statistics collected together for reference or analysis. So data is a fact. Data is something that you believe on it, I believe on it, someone else is also believing on it. For instance, if temperature is like 20, it is a fact by a thermometer, and we all believe that. So data is a fact. This guy, Edward Deming, is a well-known person. You can see from the link at the video link for Edward Deming. He's still famous. He was famous after the Second World War. And this is one of the famous sentences from him that he says, without data, you're just another person with another idea or opinion, which is completely true, isn't it? That when you don't have facts, when you don't have data to support your thoughts, you're just another person with an idea or opinion. If you say that the weather is cold, but you don't have the temperature, I would say that it is warm, because we're different people with different sort of like thresholds. So it is completely different. So without data, we're just different people with different opinion. So another thing that we have, should we trust the judgments without data? This is what I was telling, when the weather, you say that the weather is cold, for someone else it might be warm, depending where they are from. For someone from Alaska, for instance, 2 degrees, it's not cold. It might not be cold, so depending on the person, obviously. But from someone who is from a warm country, 10 might be even cold. So should we trust our judgment um, um, without any data or facts to support it? So again, Edward Deming says that in God we trust, all others must bring data. So if you don't have any data, essentially what you say is just an opinion that you're sharing with others. But why not just trusting our experience? This is a very nice article that you can read. It's not a long one. Always like to share with students. It is published on Harvard Business Review. It says, "Don't trust your gut." So the feelings, the experience that we have. Um, it is again because our feeling depends. I mean, our experience or our gut or thoughts or depending on our way of living, our backgrounds, the country we're from, culture, or other stuff. So it's not something which is unique and it can everyone believe and accept. That's why we shouldn't trust our gut. We have to bring data and facts to make sure that what you're saying is supported and it is accepted by everyone. So here you can see that essentially we have data is everywhere. We have lots of data being collected, being shared on daily basis. Everywhere around us. So if you have the data, well, we shouldn't use data rather than only trusting our feelings and experience. So here on this slide, you can see they're not up to date, I wouldn't say, but you can see here the amount of data being collected on internet. So YouTube, for instance, this is data from 2020, I believe. I didn't check the recent data if it is published, but still 500 hours of new video per second. And this is equal to 30,000 hours per minute, 720,000 hours per day. So you can see it goes up. It is crazy. You can see that Facebook generates 4 new petabytes of data per day, and 4 petabytes is 4,000 terabytes. And you can go down and you can see how many megabytes or how many gigabytes this data is. You may not use Facebook. I wasn't a fan of Facebook. I mean, um, in the recent years at least, I didn't use Facebook for a long time, but then I saw that in the country, Facebook is used a lot. If you go somewhere to a pub, for instance, if you ask them about the opening hours, they say, "Oh, are you on Facebook?" No, I'm not. They say that, "Oh, yes, we share them on Facebook." There are loads of other stuff, important information that I can only access from Facebook. So if you don't use Facebook, it doesn't mean that it's not being used in the world. Still, it's very popular. With the generation, it might be a different generation than yours. Twitter, or now being called at X, there are around like 6,000 tweets per second, which is 350,000 tweets per minute, and it goes until like 500 million tweets every day. And the other number, I don't want to even read the number, so you can see it a lot. Instagram might be something that you use more often. At the time of this data, when this data was released, it was 1 billion users in 2018, and in US alone, it is 110 million users. So in 2018, it is like 1/3 of the population in the US, which is a lot. Amazon, in September 2020, the revenue was almost $100 billion. That is crazy. And you see the amount of data that they use to just make a better system. It's just ridiculous. Now, why data visualization? Numbers are nice, aren't they? So yeah, why do we use data visualization? I'll have in the next few slides. You can see these slides. These are from some movies. Is there anyone who remember which movie this is? Feel free to write it on the chat box. Do you remember which movie this is from? I mean, this screenshot is from which movie? Is it so? No, it's not. I don't remember the name. Sorry, I forgot it. In the morning, I told myself that I'll have to Google it again because I forgot the name of the movie. But it's not so. If someone write the correct one, I will remember it. But I don't remember this one. War Games. Yes, fantastic. Okay, this is War Games. Yes, thank you. So yeah, this is something. This is a screenshot from the movie. Another one. If I move on, this one you can see again. This is from a movie, and you can see all the purpose of showing you. I will tell at the end of the last one. This one you can see again. This is from a movie. This is also from a movie. The reason I'm showing you this is in all of them, this is sort of like visualization. It's not a simple text being shown in the movie. Here you can see it's more of, this one is a plain, I mean, a simple visualization, but this one is a more sophisticated one. This one is really sophisticated. You shall see that at the time when the movie was people watched the movie, it was a sort of like, have like yes, Avatar and other movies that they showed here. So you can see that in the movie they use visualization because it is first sophisticated and it is something which is understandable by general audience. What I'm saying is in terms of like general audience, I mean people who don't have a background of like mathematics or something like that, any person that you see in the street, they can understand, oh, this is a visualization, they can understand the point of showing this stuff. So that's the reason that visualization is used. But is visualization something new? Is it something that, because I'm pretty sure that you heard the name of Tableau and also the name of Power BI maybe recently in the last like 10 years or whatsoever, or with the growth of Python. You can see lots of visualization, nice ones are everywhere that you can see. But is it something which is new? It's not. This figure that you can see here is arguably the first visualization that we could see in the history. I mean, there are lots of visualization, not the first in the history, but a proper visualization that these days you may recreate something like this. So this was created by William Playfair in 1786. So more or less like 250, almost 50 years ago. William Playfair is renowned as a father of data visualization that we know here, the visualization that we know here. I know you can see visualization on the stone in the Stone Ages, those stuff, but the visualization that we know it today. William Playfair is the creator of bar chart, pie chart, and line chart. That we will cover them. I'm pretty sure that you had these names. His chart here represents whether England was importing or exporting more to Denmark and Norway. So here you can see this is very nice that we have the years. This is a really smart way of showing the data. They went to the king or queen at the time. I don't remember if at the time it was a queen or king in the country in England. But this is very smart that rather than just reading them data and telling them, oh, in 1700 we exported this much, imported this much, in 1710 we did this and that. It's really easy to have them in a chart like this. So this, you can see here on the x-axis we have the years, and on the y-axis here this is the amount of export and import that we have from to and from Denmark and Norway. And you can see at some point here the export is more than import, so it is a good sign, isn't it? If you export more, you have more money in the country, whereas here until like 1754-ish the import was above export, which means that this is something which is not good. So here is the breakpoint that the export became more than import. Here you have another one. another old visualization, which is a nice one. It's not the best that you could do to visualize this specific data, but still at the time it was a very nice one. This is one created by Florence Nightingale in 1858, and this is for the war in England, and it is called a coxcomb chart. And this is a diagram of the causes and or mortalities in the army in the East. At the time, there was a war, and Florence Nightingale, who was a nurse, she's famous for not for no, for this visualization, but for a modern nursery. So there are lots of hospitals that you can find around the world with her name on them, because she started this modern sort of like treatments and nursery and those stuff. So here, this in this coxcomb chart, you can see there are different colors that we have. We have blue for the disease and red for the wounds, and black for other causes of the death for the soldiers in the army. The right diagram in the first half of the war, and the left part, left chart is for the second half. So second half of the war. So you can see the essentially the month of the year here, when for the time essentially that she visualize the data. This is one of the earliest example of controlling epidemics. So it wasn't war itself, but there were like other reasons based on the chart and the data she collected. She realized that it's not only the war itself that brought the mortality, but there are like other sort of diseases were spread among the soldiers. There is another example here that you can see. This is done by Charles Minard, Napoleon army. This is the war between France and Russia. It was created in 1869. As you can see here, there are like 60 different types of information which are like presented here, like geography, time, temperature, the course and direction of the armies, movement, and the number of troops remaining. So it's a very good one, and I guess this is essentially the border of France and at the time with Russia, where the war was there essentially. So I'll leave it to you. If you wanted to have a closer look, you could just click on the link and you can have a look and see that. So data visualization. So I showed you, you can see first, data visualization is everywhere, and then it's not something new. The modern visualization, as I said, started in like late in the 18th century. We use data visualization, and again, what is visualization? Data visualization is the translation of data from big tables and numbers into visual format. This is what we do, rather than, so all the visualizations that I showed you here, there were some data, some numbers on paper at the time. In this in these days, you would find them in Excel file or others. They became visualized in a visual format. When we have visualization, they enable trends, correlations, outliers, and errors in data to jump out more quickly when visualized, rather than just having the numbers. We'll see a few examples. Leveraging human cognitive functions which respond far more quickly to visual stimuli. This is something that we know, right? Something that with your eyes can see, it's, which is like visual stimuli. It is easier compared to other methods. So this is essentially a brain hack. So visual analytics is the representation of presentation of data that exploits our visual perception abilities in order to amplify cognition. So this is from Andy Kirk, who is a data visualization specialist, and there is a very nice book on visualization I'll put the link here that we can get some information from. So as I said, we can see visualization everywhere. If you have a smartwatch, this is the visualization of the data that you have for your heart rate. It might be for your sleep, sleep information. It can be for your exercise or anything like that. The London Tube is another famous example of data visualization. Recently, I learned that this is not the correct like directions, those stuff, but this is the only way that they could visualize the London tubes like lines. If you're into e-sport like games, you can see an example here. Cars dashboard again. It is a data visualization. So in the new cars, essentially, you don't see the actual thing, and it is a dashboard which visualizes the data that receives from the computer in the car, in the airport, and also in the airplane. Hans Rosling is a very famous person in data visualization. We'll try to recreate the data visualization that he created here. He created one of the most famous and most effective visualizations showing through animations the changes in fertility rate and life expectancy since 1960s across the world. This is a bubble one, but it's not only a visualization, it's an animation that you can see the changes, etc. So Hans Rosling is a Swedish physician, academic, and a public speaker. So the link to one of his speech is here. He's amazing in as a speaker, a good academic, a good physician, but in terms of speech, that's he's amazing. So you can see from this link here. I'm not going to show you this. If you would like, you can just have a look at it when you're at home. You can see the link on the slide. I have another example of why data visualization is important. We have Anscombet's quartet. There are 4 different data sets that we have here by Francis Anscombe in 1873 to show the importance of data visualization. So we have the first data set, the second one, the third one, and the fourth one. If you look at the statistics of this data, like mean of this data sets, the variance of this data sets for X and Y. So these are like data sets with 2 dimensions, X and Y, each of them, each point has, and you can see the variance, the mean of X and Y, the variance of X and Y, the correlation between an X and Y, and the linear regression. You can see for all of them, for these 4 data sets, more or less, you're the same. So you think that these data sets look like each other completely. But if I go back to this one, said that if we have data visualization, we can see the trends, correlations, outliers, and errors more effectively and quicker. So that's what we're going to see here. As you can see, this data set, they say very similar, not very similar, exactly the same statistics. But when we visualize them, we can see that they have completely different sort of trends. This is the first one, this is the second one, this is the third one, and the fourth one. So having the data in front of us with the statistics even, still we can be misled, but with the visualization, easily you can see the trends, correlations, and other stuff. Now, again, I don't want to go back to that slide to show you why data visualization is important. One other thing was, quickly, we can see errors, outliers, those stuff. This is a data set, the measles outbreak data set in USA, which happened in 1928. And this is the data that we have. Essentially, the data what we have is different states in the United States and different years that we have, and the number of cases of measles that they detected. So this is typical operational data reporting business. It's just a dump of data. When you ask for a data set, normally they provide you with Excel as Excel file or CSV. Both of them are the same. JSON file is something that they use these days, but I always came across Excel files when you ask a company in business, in industry, to share some data with you. You will have a dump of data as an Excel file. it's even too much data to fit in a single screen. You can see you have to scroll down, you have to scroll right to see the data, because you may have too many rows, too many columns. So it's not even possible to see the whole parts in a single screen. Therefore, you can see what is hiding in different parts. If you go down, you may see very important information. If you go right, if you scroll right, you will see, you may see a very important information as well. It's not possible, or let's say easy, to see any trends if they're there. If there is any outliers or breakpoints or something like that, it's not easy to see them, because it's just different numbers that you have. If there is any interesting values, again, it's not easy to see it from this Excel file. If you were to share it as it is, would the receiver be able to understand and interpret this data easily? No. Or if you have similar doubts about a data set, then visualizing it is possibly the best way to help to interpret and understand the data set in terms of like trends, correlation, outliers, and other stuff. Now, how can we make it easier to understand the data set? The answer is the name of the session that we have, visualization. So the first sort of thing that we did here is a crosstab. So this is very similar to the data that I showed you in Excel. This is the same data set, but short and wide rather than being long and thin. So the previous one, you had to scroll down a lot, but now we made them. You can see here. So if I go back here, you can see there are different years that we have. So if you go down from 1928, you would move to 1929, 1930, so on and so forth. So here what we did is we have the states here, and we just kept the years on the columns. Still, it is void, but rather than being long. But still, if you want to see all the data, you have to scroll down or scroll right to see. It is good for only two things from visual analytics perspective. If you're looking for a specific value, if you want to see exact value of the cases in California in 1938, for instance, it is 18,527, for instance. Or if you want to show missing data, for instance, Mississippi, you can see that the data is missing from 1928 to 1946, for instance. So if you want to see a specific value, or if you want to see missing values, then you can look at the crosstab. It's better than the previous one, still not the ideal one. The second sort of the visualization that we created here is a heat map. A heat map essentially is the same as a crosstab, but here we don't have any numbers. Because we don't have any numbers, the cells can be more compact here, so we can fit everything in a single shot. And then what we do here is, rather than showing the numbers, because the numbers that we have here, for instance, we have 49,000. This is much different, very much different from 5,000. But is it really important if you have two numbers, for instance, like I can find two numbers which are very close to each other, like these two, for instance, 6,435 and 6,366. It's really important. The difference is not that much. These are the number of cases, but they were not the number of deaths. Obviously, this matters as like human being, but in terms of the data that we have, these two are not really different from each other. I mean, we can consider them the same. So in a heat map, what we do is we just essentially have ranges for different colors. If it is between, for instance, 0 to 500, we give a light bluish color. If it is too high, like 50,000, then we assign them a very dark red color. Okay, so this is the same cross-tabular structure that we have. Again, the years here, and we have the states. All data fits in a single page. We use colors to show the cases, so dark brown, it's not dark red. It's 4K plus cases. Outliers are can be easily seen here. For instance, you can see here after like almost 1963, the number of cases is going down, and here you can see that most of them are blue, which means that the number of cases is so low. But here, for instance, in 1990, there are two states with dark blue, which is the number of cases is so high. So Here you can see you can seek for to find the reasons what happens. There are extra contexts that we can find from here. For instance, as I said, from 1963, you can see this. There is a sharp drop in the number of cases. It starts, and here around like 1968, the number of cases dropped drastically, which means that something happened on those days, which is the vaccine, the mass vaccine. Distribution in 1963. If there is any missing data, easily you can see here if they're like empty. Oh, these are missing data, and you can see there is an obvious reduction in the number of cases that started here after this line. There is another one that we call it small multiple maps. Maps are nice for visualization. We will try a few on next week on Monday and Tuesday. And you can see here that we have the map of the United States with different states. And here you can see that it goes for different years from 1928, 1929, etc. And you can see here, the more we go after this one, it's still a few years that we have a few states with dark brown color, but you can see it from here it goes down, and until here you can see that there is no cases that we have. So this leverages Tableau's mapping capabilities. All data fits on a single page. Still, you can see if you're on Tableau, I'll show you when if you want to see the individual data for a specific state. If you go on them and hover over the state or click on it, you will see the exact number. Again, you can see the outliers. You can see that we have all blue or no cases here, and suddenly we have two, it's two states with dark blue. Again, missing data is obvious and visible here, and obviously you can see the decrease in the number of cases. Bubble jitter plot is another one that you can see here. This is useful for distribution of the values if you wanted to see the distribution of the values rather than focusing on the states. Leverage interactive features to help insight. So here you can see that you can change the state from one state to another state, and then you can see the distribution of the numbers. Again, still you can see the outliers and decreasing the number of cases. Any questions? I presume you're enjoying this because I am somehow. You know, with optimization, which is not as easy as this one, and this is just story. So I presume that you're enjoying your morning. So what is Tableau as the software that we're going to use for visualization? As I said, Power BI is another one, which is a competitor for Tableau. You can use programming languages for the sake of visualization, like Python, as I said. But Tableau is something which doesn't need any program, which is amazing. It's the market-leading data visualization tool. So for the companies, it was a revolution to use Tableau for visualization in terms of their analytic capabilities. There is no coding or programming which is required here. It's just drag and drop that we will see, which is amazing. It's used across diverse industries. I'll show you a few of them. It is a full-scale enterprise software solution, and it was created in the US at Stanford University. This is the link to Tableau. There's the information. This information I got from the website. As I said, it was created in Stanford University. It was created by 2 PhD students and this professor who was the mind behind the visualization. He's the mind behind Pixar Studio as well. He's got 3 Oscars, and you can go and check the link for the professor. Amazing in visualization, as I said, in animation and those stuff. This last one was a very recent Oscar award that they received. Who uses Tableau? Many companies like Audi as like manufacturer, one of the biggest manufacturer of the cars. There are like eBay, Facebook, universities, LSE London School of Economy, Google. You expect them that they use Amazon, Coca-Cola. There are many Premier League or football clubs in this country, in the UK, that they use Tableau for the sake of visualization, because this is, as I said, visualization is can be easily understood by everyone, the public audience, and it is easy to make visualization using Tableau. There are politicians that they use Tableau. In the US, when you have a campaign for the election, you have to share the cost. The cost of how did you spend the money that you had for the campaign, specifically on different parts. Barack Obama, Trump, and Hillary Clinton, in their elections, they use Tableau to buy the lenses and use it and use the visualization as a part of their election campaigns. If you know Boris Johnson, who was the former Prime Minister of United Kingdom, was recently again viral because of his comment on ChatGPT. You apparently came across the video that he's telling that, oh, I love AI, I love AI, and I love ChatGPT. The way that he pronounced GPT is a bit like funny. It was a funny man, I guess, and when he was a mayor of the London, and also the Prime Minister. During COVID-19, as I said, NHS uses Tableau. Boris Johnson used to give the daily cases in the first days and then weekly cases. And he used to use Tableau for the sake of visualization to show the number of cases every time he was reporting the number of cases. I'm just checking the chat box. Why do we pick Tableau over Power BI? Because, as I said, it is the market leader used by many companies. The competitors, obviously, we had to make a choice, and for this module, they started using teaching visualization by someone who was from a company that they are market leading in visualization, and they use Tableau, and we continued using Tableau. As I said, both of them are market leaders. Tableau has more, a wider users across the board. I have the same question. I have worked with Power BI, never with Tableau. Which one is better? But who knows? Without data, you're just another guy with an opinion, right? If you check the number of users, might be close to each other, but it's the choice that you have to make, right? I can't say if Power BI is better than Tableau or Tableau is better than. You may like Power BI. I like Tableau. I used Power BI, but not, serially or for teaching. As I said, it is called the market leader at the moment in the last few years. So that's why we have Tableau. Right. Okay. What can we do with Tableau? There are lots of stuff, visualization that we can make. You can see these are like visualization that these are the visualizations which are publicly available. If you go to Tableau public website, you can create an account on Tableau public where you can share your visualizations. People also share their visualizations, as you can see, nice ones. It's like GitHub, like Kaggle, that you can have an account and you can share, you can compete, you can see others' output. So these are some examples from sorry. These are some examples that you can find on Tableau public. There are very nice ones that you can find. Many of them interactive. These are the ones that you can find there. So visualization is one of them. You can create dashboards. It's not just a single dashboards, or not single visualization from a data set, but you may have one single screen where you have different visualization from different data sets related to each other. Obviously, it's not one of them from like related to football, the other one related to uh, financial situation in another continent, for instance. So they're related to each other, but there are lots of them being next to each other that we will see a few of them. If I show you Tableau's interface, I'm hopeful that you guys have already seen this, because I ask you um, to install it. If you haven't, please do install Tableau for the workshops on Monday and Tuesday. So here what we see is this is the when you fire it up, the Tableau software, you can see this screen. Um, I don't have this part, I guess, because I didn't sign in or something like that. But normally you will see this, these examples from Tableau public that you can open and work with them. You can change them. So here is where we have the data connection. There are several sorts of like data files that you can import to Tableau. So in Excel, what you do is you have the data and you create your visualization that you want. You can create a pie chart, you can create a bar chart or something like that, a line chart in Excel. You can do the same here in Tableau. You just connect the data that you have. Once you have the data, you can do whatever that you want to do with it, and it's only drag and drop that we will see. So there are different flat files that we can import here: Microsoft Excel, text file, JSON file, PDF file, etc. But as I told you, if you work in the industry, you will see that it's just Excel file that is mostly used. Databases that we can connect Tableau to them is like Oracle, it can be Amazon, it can be Google Sheets, other stuff. And here there are some saved data sources that you may have. I will share with you a few data sets that we will use on the workshops next week. If you click on more here, you have more here for the flat data and also databases here. So you can see lots of them, that we have lots of different connections that you can make here with Oracle, with OneDrive, almost everything. List differs slightly between Mac and Windows, by the way. So if your computer is different, I mean, I have a Mac, the one that I use for teaching. If yours is Windows, what you can see here might be different. Some databases do not allow connection from Macs, but it's not something. I mean, it might be a niche sort of like database that we have. ODBC and JDBC options allow connections to other databases not on the list here. So if you find ODBC and JDBC, physical databases and cloud technologies are all here. Comprehensive Google Suite connections, web data connectors that are the community built JavaScript API connectors, and you can make your custom connectors. But as I said, what you have there is more than enough. It might be 1 in a million that you will need to create your own bridge. So this was how to connect data. Once you have the data connected, that we will do on Monday and Tuesday, you will see different tabs of the data set that you have. The data set that we will work on is EU Superstore data set. This is a sample of a retailer where you can see the order, people, the returns, the prices, sales, profit, and many other information that you can see, the way of like delivery or the time it took to deliver, so on and so forth. So what we see here after importing data, here you see the source name and type that we have. Here are the tabs and tables that we have in the data set. And this is a preview of the data that we have. So you can see it's a massive one. This is exactly what you would see in Excel for different tabs. For instance, this is the data on order, for instance, I believe. Here you can see the data source order that you can change it. These are the data type icon that we have. You can see there are different sort of, let me zoom in, that's very nice. So here you can see that there are different icon that we have for different data types that we have here. For instance, this is ABC, which means that this is a string because this is the order ID. This is also the ship method, which is like standard, etc. This one is a calendar for the icon, and this shows that this is essentially a date that we have here. If we move on for this one, I guess don't have. So these are like map, for instance. You can see a globe here, which means that this is something related to a map. So the essentially these are the cities, the states or the countries, the region, which is name and it is a string, so on and so forth. So if you have anything which is like number, you can see that we have a hash here, so it shows us this is number. We have connection types, which can be live or extract, and the filters that you may add to filter the data. So here is essentially some information on different data icons, data types that we have. As I said, ABC is string or text field, and we have calendar, globe, and hash for numerical field for different data types. Tableau is amazing in detecting what type of data you have there, but still, if you notice that an icon or the data type is not correctly given, for instance, this is ABC, which is a string, but the data that you have is numerical data, you can just change it yourself. But as I said, it's really rare that you get a wrong one. As I said, there are two different types of connections. It can be live or extract. If it is live, you can see a visual indicator here which shows single cylinder there. Where it is. I just wanted to show that one. Couldn't find it on this one. This is the one. Yeah, sorry, this is here. So this is what you see here, which is a single cylinder icon, which means that the data is live. So when you have live connection, so it is lively connected to the data source, which is very nice. Data will be updated on manual refresh or when a Tableau workbook is open. There is a disadvantage here, which is a latency. So if the data that you have is a massive data set, if you have it live and you want to use different tabs, for instance, or other stuff, you may have latency, which can be resolved if you use extract data. So here you can see we have a double cylinder icon here. The type of the data that we have is .hyper, which is compressed, and you can just refresh whenever you want, or you can set on your setting that you want when you have extract data rather than live, you want to refresh every 15 minutes. So if there is any change in data that you have, every 15 minutes it will be refreshed, so you have the latest changes in the in Tableau as well. Again, as we said, there are like data connection types. As I said, these are some information for extract. I'm going to go a bit fast as we are a bit short. You can go through them. As I said, this is for scheduling if you want to do it yourself. So when you have a visualization, there are different sort of things that you can see on the screen. Here on the left hand side, you can see the data source, the name that you have. This is live. You can see here there are dimensions that we have, and we have measures here. You can see that the colors are different, that I will speak about them. Here we have mark cards and other shelves. You could try a few of them, how you want to represent data essentially. And here you can see that we have column and rows where we drop the data that we drag. You can drag from here, from dimension or measures, and you can drop them here. And here you can see the legend for the data that you did. Show me is where you can change the type of the visualization from a bar chart to a pie chart, for instance. I would recommend not to do that because Tableau always decides on the best one that you have. When you click on anything, measures and dimensions, and try to drag it, you will see some orange highlighted parts that you can drop the data here, filters or pages, or here, or essentially on the column and rows that you will have the option to drop the data. In Tableau, each chart is created on its own worksheet. There are like different worksheets that we have here that you can create new ones on each one. It's like the tabs that we have on Excel as well. Dashboards are collections of worksheets, not a single visualization, as I said, a mixture of them that you can put them together to see them better. Show me, as I said, it's a chart wizard that you can change the type of the data that you have. Best not to use if possible, as I said, because Tableau is always the best to decide it there. For dashboard interface, so you can see here that you can choose dashboard, and as you can see here, you can drop different visualization that we created on different, you can see here, different watches that we have, bubbles, bars, maps, and lines, and now we have a dashboard that you can just drop them either as image, text, or you can have something which is interactive. Blue and green are different color codes that we have here. Blue is for discrete values which are countable, and green is for the ones which are continuous. So if I go back here, you can see that this was the measures are, sorry, the dimensions are blue and the measures are green, which are continuous. So here you can see that essentially here what we have, blue and green for the measures and for the dimensions if they are so you can see subcategory which is countable or it is discrete, it is blue, and for the axis which is for the other axis which is sales and it is continuous, it is green. You can save data file as TWB or TWBX, or to comment TWBX. When you use TWBX, it contains the data as well. So when you send a visualization, the data set will be also sent, whereas when you have TWB, the data set will not be sent. So it's better to save any data as TWBX. You can save worksheets as we do in other sort of like programs that we have, like Word or Excel, that you can save them. You can save worksheets as images in order to embed them in other technologies. You can save them as the PNG, PMB, BMP, or JPEG, etc. So you can see here that you can export them. For the dashboards, if you want to export them as an image, again, you can do the same. So here you have to go to worksheet, but here for the dashboard, you have to select dashboard and then select export image, and then you can choose the different sort of image that you want to do. Final touches, and we will let you go. There are free repository for your dashboards. As I said, is Tableau Public that you can use it. Tableau Public is published directly from Tableau Desktop. So what you install on your computer is Tableau Desktop, and then directly you can share it on Tableau Public on your account so that others also can see. And there are loads of nice visualization and dashboards that you can find there. So these are some information on Tableau Public, which are like simple like examples that you can find there. Okay, let me just go because I just want to yeah, for Monday, the first portion on Monday we have. What you can do until Monday is you can create your Tableau Public profile. If you add a nice visualization, we can just publish it there. Don't forget to install Tableau, play around with Tableau. It is super easy. We will practice in the workshop. There are like further readings that I'll put here for the links, so that if you are interested in, you can have a look and get more information on Tableau. Fantastic stuff. I'm going to stop. Sorry, with slightly late, but it's not that late. So these were more or less the slide that I wanted to cover. There's some information there, like shared with you, so you can go through any of them and ask any questions on Monday or Tuesday. If you have any questions, you can stay and ask me. Otherwise, feel free to leave. I will see some of you today for the workshop of optimization, but I will see all of you on Monday and Tuesday for the workshops. Have a lovely weekend. Questions? Does Tableau have an AI assistant? I'm not quite sure. What you mean, like, oh yeah, like Copilot? I don't know. No, I didn't see it. I mean, I didn't see that. So on if you remember on Anaconda, if you sign in, you can't see the AI assistant. But on Tableau, I didn't see that. I didn't notice, to be fair. The slides are already posted on IWS. In the first slide, so I'm answering Amber's question. The first slide that we have here. You go to help and then manage product key. And once you clicked on that one, activate, and then here activate with the product key if you got a license, and then just put it here and you can activate it. So it is in this slide. Is asking for product key for activation. As I said, if you sign in as a student, you may be able to have the license. I guess you have a free license. I mean, free usage for 14 days. After 14 days, either you have to give a license or you have to be registered as a student or an academic. I mean, for academic use. So, for me, it didn't ask for any for any license on this computer because I have other computers and I have Tableau on them, but I didn't have on this one. When I was installing this one, just sign in on my account and I have Tableau, and it didn't ask for any license. Where can we find these slides? My WBS? I shared them yesterday. Let me just see. Week 7. That's weird. I'm pretty sure that I put it yesterday. I put it in the wrong week. No. Sorry, guys. I was maybe in the previous years. I don't know. Sorry for that. I'm just sharing the slides. I'm sorry, I was pretty sure that I shared the slide, but I haven't. I just shared the slides on my WBS, so you should be able to see it on there, week 7. Might be for Tableau Public. How can we get the license for Tableau? Under the same, if you go on, if you follow the steps that I shared in my announcement a few weeks ago, you should be able to see that. So this is the way that I did, and I have Tableau on my laptop, not Tableau desktop, and the features are exactly the same. Okay. Any other questions? I'm gonna stop recording because we don't have other questions. I will stay here for a few more minutes, but I don't want to just staring at the desktop. I'll see you. Have a lovely